Good day, students. You are welcome back to this channel. In today's class, I want to explain linear and non-linear differential equations. A differential equation is said to be linear. A differential equation is said to be linear if this general formula is satisfied. Let's say we have a naught n y x n plus a subscript 1 n minus 1 then y the x n minus 1 plus a 2 n minus 2 y then the x n minus 2 plus a n minus 1 then the y the x then plus a n y is equal to q of x, where a naught, a subscript 1, a subscript 2, and so on are either constants or functions of x. So a differential equation is said to be linear if it is in form of this general equation. So what can we deduce from this general equation? The first one is that the maximum degree is 1. The maximum degree is 1. 1. That is, if you look at everything here, all their power, the exponent is 1. So we cannot have y squared, then we cannot have the squared y, the x squared, all squared, or the cube y, the x cube raised power 5, and so on. So this one, all these ones are not allowed in linear differential equation. So the maximum degree is 1. Look at it. The maximum degree is 1. The another one is that there is no product of dependent variable with the derivative. For a differential equation to be linear, you cannot have the product of the dependent variable y with any of the derivative. You cannot have it with the y, the x. You cannot have it with the cube x, the x cubed, and so on. So all these ones are not allowed in what? In linear differential equation. The third one, the nonlinear functions such as sine, cosine, tangent, exponentials, logarithm, natural logarithms involving dependent variable or its derivative do not exist or occur. That is, for a differential equation to be linear, you cannot have something like this. I cannot have the y, the x plus sine y equals 0. So, no, this is not a linear differential equation. So, it is not a linear differential equation. So, then I cannot have exponential y plus d squared y dx everything raised power 2 equals y dy dx. So I cannot have this one as well. So for this one violated the third rule. I cannot have the exponential or logarithm of dependent variable in linear differential equation. Then the maximum degree must be 1. So this one has violated the rule number 1. This one violated the rule number 3. So all this, the rule number 1, rule number 2, rule number 3, if they are violated, that means that is not a linear differential equation. Okay, we are saying they are not linear. So let's give examples of linear differential equations. Examples of linear differential equation. 1, we can have the y, the x plus 2xy equals 0. So this is what? From the last class, from the previous class, this is what? First order differential equation. And it is still linear. So this is first order linear differential equation. So why is it a linear differential equation? Differential. It is a differential equation because the maximum power, the maximum degree here is 1. The power of this one is 1. The power of this one is 1. The power of this one is 1. The other one, there is no product of dependent variable with the derivative. So I only have the product of the independent variable with the dependent variable. That is allowed. Then there is no sign or exponential of y, exponential of the y dx, and so on. So that makes it a linear differential equation. Another one, we can have y equals d squared y dx squared plus x. Yes, this is also a linear differential equation because the first rule, the maximum degree here is 1. Then there is no product of y with its derivative. Then all these ones, there is no sign of y, no exponential of the y dx and so on. So that makes this one also a linear differential equation. So is it a first order, second order, third order? It is a second order. Why? Because the highest differential coefficient here is 2. The highest derivative here is 2. So this is what? Second order linear differential equation. So you need to understand all this one. The rules, you have to follow the rules. The maximum degree must be 1. There must be no products of dependent variable with the derivative. Then the nonlinear functions such as sine, cosine, tangent, exponential, logarithm involving dependent variable or its derivative must not occur. So in the next class, we are going to do non-linear differential equation. Till then, thank you. Bye bye.